So these four things, basically the role of percentage here. Percentage allows us to compare things, to put them in perspective that we have 100 parts of something. So it allows us to compare. Okay. Now percentage yield is related to product. Okay. And purity is usually related to reactant. So that's one thing you have to remember. That product usually compares with yield and reactant compares with purity. Of course, they affect it. If you have an impure compound, your yield will be reduced. So they do affect each other. But when we are dealing with calculations, we usually keep product for yield and reactant for purity. So what exactly does it mean? So we just did an example where you saw that, okay, 36 gram calcium was reacted. 36 gram calcium, you had a mixture of calcium in which you didn't have 36 grams of calcium, you had the 36 gram total mass. Okay? So whatever total mass was there doesn't really matter because in a reaction like this, calcium is the one that's reacting, and impurities usually we assume they do not react. So it's not the 36 gram that will react. So let's suppose in the same reaction, they said it was 20% pure. So instead of saying that all of this happens, the question was phrased in a way that 20% pure sample of calcium was reacted with uh, 1 mole per dm cube nitric acid. ठीक है? Figure out या calculate mass of sample. Now here's the thing. What this is telling me is that I can use calcium in my calculations, but whatever mass of calcium I actually find out, that's 20% of the total mass. It's not the total mass that's reacting. It's only calcium in there that is reacting. We'll have, okay, we have acid there. To react them. So this calculate. Equation is important because equation tells us the mole ratios. Okay. Here you go. Calculate. So we have mass of calcium on one side and we have moles because it's a solution. For solution, we can only compare moles. So mass of calcium is unknown, but we know that from the ratio, one of this reacts with two of this. So that is standard value is 40. It's the AR of calcium. So 40 gram calcium reacts with 2 mole nitric acid. Okay, fair enough. Now we plug in the values. We do not know this, but for this we know concentration is 1 and volume is 20 over 1000. Okay. Now we do cross multiplication. So we will get that 40 times 20 over 1000 equals 2 times x. Okay. So you do the calculations, you are left with x. So this is telling me that 0.4 gram of calcium actually reacted. Now, how much was it in the sample? The sample was 20% pure, which means only 20% of the total mass was calcium, which is 0.4 grams. So what was 100% of the mass? It was X, right? So that means I'm going to see that 20 times X equals 0.4 times 100. So X equals to 2 grams. Now, did I have 2 grams calcium? No. I had 0.4 gram calcium. But because that only made up 20% of the sample, the total sample, whatever we started off, must have been 2 grams because 20% of that is 0.4. Okay. So this is the idea of percentage purity. How do you figure it out? You either have the percentage purity and you figure out the total mass of the sample using that, or you calculate the percentage purity based on how much was actually reacted. Let me give an example of that question as well. So here's a question. It says that 2 gram sample of calcium carbonate reacted with an excess of 0.5 mole per dm cube. An excess simply means that there is no limit to how much volume it actually used. Okay. Now the gas collected was 48 cm cube. What was the percentage purity of sample? Now here's the thing. Let's try to make an equation for this. So we are reacting calcium carbonate with HCl. So we know that it will give off carbon dioxide, calcium chloride, and uh, water. If you don't know how this reaction happens, that's perfectly fine. We will be studying acids and bases soon. So for that, just wait. So this is the reaction, and we know that carbon dioxide is the only gas that is being given out. And right now, what do we know? We know that 48 cm cube of this gas is being given off. Okay. And calcium carbonate sample is unknown. Why? Because the total sample is 2 grams, but it's possible that not all of it actually reacted. There was some part of it that was calcium carbonate which reacted. So let's figure it out. Let's see what, and by the way, we already have all concentration of this, but as it turns out, it's quite useless. We don't really need it. We don't need to know the concentration of HCl because we already are just comparing calcium carbonate to carbon dioxide. तो ये हमें उसने extra information दे दिया. This information overload does happen and you have to be careful to just discard extra information. Okay, so let's compare this. We have mass of calcium carbonate and we have volume of carbon dioxide. So let's use the equation. Equation says 1 mole of this will give me 1 mole of this. In other words, one of this has 100-gram mass and one of this has 24 dm cube volume, right? So those values I get from the standard that I remember, that 1 mole of any gas is 24 dm cube and 1 mole has 100 grams for calcium carbonate because it's its MR. Okay, so how much do we have? We do not know how much we have. And that is the most crucial part of this question. They're saying there is a 2-gram sample, but that does not mean that all of it is calcium carbonate. Until and unless we know that it is, we cannot figure it out. Okay, we cannot say that, oh, 2 grams is the mass. It's not. It's 2 gram of the whole thing. Out of it, some of it is calcium carbonate, which we don't know how much. But the volume is 48 cm cube. I'll divide by 1,000 to figure out कि वो क्या है. Okay, so we solve this. So cross multiply 100 times 48 over 1000 equals to 24x. So this cancels out. We have 4.8 equals to 24x. So when we divide it, 4.8 over 24, that is equal to what? That is 0.2. So this is telling me that actually only 0.2 gram calcium carbonate was present because only that reacted. No? If it was more than that, it would have produced more volume of gas, but it did not. So 0.2 gram calcium carbonate is responsible for 48 cm cube of gas that was collected. Okay. Now, what does that mean? That means that out of the total 2 grams, which were in the beginning, only 0.2 gram was calcium carbonate. Everything else, assuming that impurities did not react, we can safely say that 0.2 out of 2 was the pure calcium carbonate, which I when I multiply by 100%, I get 10%. So this is telling me the purity of the sample. This is telling me that 10% of it is pure and the rest of it is simply impurity. Does everybody understand this? So we can use the idea of purity to figure out how much product will be made or how much purity was there or how much actual mass of the thing was in there. Now, obviously, purity affects yield, and yield is the same thing. Just like purity is applied to reactant, yield is applied to the product. So you do the whole calculation as you would, and yield simply tells us that how much you expected, okay, compared to how much you actually got. So the formula that famously people put is yield is going to be similar. Purity के बारे में भी लोग formula क्या है? That it is the uh, practical value over theoretical value, okay, into 100%. That goes for purity, or in other words, purity के लिए आप ये कर लोगे कि pure over total mass into 100% gives us the percentage purity. If you don't want to use uh, this unitary method. Similarly, for yield, people say that is the practical value compared to theoretical value times 100%. लेकिन practical theoretical होते क्या है? Basically, practical value is the one that they tell you. In exam, you cannot calculate this. Okay? So this is always given. And theoretical value is the one you got through calculation. So this is calculated. जैसे यहाँ पर 0.2 ग्राम कैल्शियम मैंने कैलकुलेट किया है कि ये इतना होगा, मुझे तो नहीं पता कि एक्चुअल में रिएक्शन में ये है कि नहीं है, वो तो हमें वो बताएगा ना. तो theoretical is the value that you calculate and given value is the practical value. So let's say we have a simple reaction, we have a reversible reaction, and they say, okay, sulfur dioxide reacts with oxygen to produce sulfur trioxide. Okay, and it's a fairly low yield reaction. So they say that 720 dm cube SO2 was used to produce. Okay, so it's a simple question. You have to figure out what does this 240 mean here. This 240 is telling me that this is the practical value, the value that they got. वो रिएक्शन तो इसका कर रहे थे ना, ये उसकी वॉल्यूम है. 240 नहीं आना चाहिए था. It should have been more, but because this has a low yield reaction, तो वो उतना प्रोड्यूस नहीं हुआ. So let's figure out how much should have been produced. So we are comparing volume of SO2 with volume of SO3. So we're do for 24 for this as well. 720 here, because you have to calculate the theoretical value. वो x है, वो हम calculate करेंगे. तो हमें पता लग जाएगा, आप calculation cross multiply कर लो, you will figure out that it's actually 720 dm cube. And makes sense, वो 720 है तो ये भी 720 होना चाहिए, because mole ratio is the same. And for gases, mole ratio is the volume ratio. Now
सर
let's
एक चीज
figure out
समझ
the
नहीं आई सर.
percentage yield. Yield is basically the idea. कहाँ से?
सर ये जो आपने ऊपर रेशियो मेथड किया, वॉल्यूम को वॉल्यूम से कंपेयर किया.
देखो, रेशियो मेथड टेल्स मी दैट, ये लाइन समझ आ गई?
नहीं सर.
देखो, first line is always about the standard values. So we are comparing volume of gas now. So what is the volume of 1 mole of any gas? 24. यहाँ पर हमारे पास रेशो क्या है? 2:2. तो मैंने बस सिंपली वो 2 कॉपी किया है और वहां पे मैंने स्टैंडर्ड वैल्यूज लिख ली है फॉर 1 मोल. 1 मोल के लिए 24 होती है, चाहे वो SO2 हो चाहे वो SO3 हो. मैंने वो दोनों साइड पे 24 लिख दिया उसके लिए. ठीक है. अब यहां पर मैंने गिवन वैल्यूज लिखती हैं जो मुझे उसने बताई हुई हैं. यहां पर मैंने लिखते हैं स्टैंडर्ड वैल्यूज. सो गिवन वैल्यू इज that 720 dm cube of SO2 was used. So I would expect 720 dm cube of SO3 to be produced. But वो उतना नहीं हुआ.
सर तो SO3 का वॉल्यूम 240 नहीं होना
हुआ
चाहिए?
कितना? 240. होना कितना? So we multiply actual value. This is the value that we got. ये है नहीं. आप कोशिश कर, उस कोशिश का नतीजा 100% ना आए तो वो कितना आता है वो यील्ड है. सो 240 इज द वन दैट इज प्रोड्यूस्ड, जो एक्चुअल प्रैक्टिकल वैल्यू है. लेकिन कैलकुलेशन क्या बता रही? कैलकुलेशन कह रही है कि 720 होना चाहिए था. अब वो कोई भी रीजन हो सकती है. मे बी इट वाज इम्प्योर, मे बी द मशीन वाज फॉल्टी, मे बी द अमाउंट वाजंट कैलकुलेटेड करेक्टली. 100 different factors can affect it. So this is going to tell me that okay, the yield was that where I should have gotten 100%, I got 33%. So that is my yield. My reaction is producing 1/3 of what I want. तो इसके लिए फिर हम क्या करते हैं? हम yield को improve करने के लिए हम try करते हैं कि हम ज्यादा pure चीजें use करें, हम ज्यादा अच्छे तरीके से reaction करें. We try that we keep the conditions of temperature and pressure under control. we try to use catalysts. Actually, catalysts don't improve the yield; they just affect the rate of reaction.
So next idea is basically percentage by mass. That is actually one of the easiest topics. Percentage by mass basically deals with how much of any element is present in the total. So let's take any example. Let's say we have H2SO4. And I want to figure out how much of that is sulfur, how much of that is oxygen, how much of that is hydrogen. So first thing I have to do is take the MR of the whole thing. So 2 hydrogens, 1 sulfur, 4 oxygen. Okay. So I plug in the values 2 times 1 plus 1 times 32 plus 4 times 16. That gives me 98. This is the total mass. Now I want to figure out how much of that is hydrogen, how much of that is sulfur, and how much of that is oxygen. So how will I do that? I will take hydrogen. So I have 2 hydrogen where total is 98. And I multiply by 100% to find how much of that is hydrogen. For sulfur, I have 1 sulfur out of total 98. I multiply it with 100% to figure out how much that is. Same for oxygen. I divide by 98 to figure out my 100%. So this is same figure out how much of that is present. This also happens when you have water of crystallization. Let's suppose I have copper sulfate with 5 water molecules in it. And I want to figure out how much of the total mass is water. So I'll simply be like, okay, I have 5 water molecules where the total is copper sulfate plus 5 water molecules into 100% कर लेंगे. तो total mass और relevant mass का जो ratio है, that is called percentage mass. So 5 water is 5 times 18 because water's MR is 18. Copper sulfate, copper is 64, sulfur is 32, oxygen is 4 times 16, then again 5 times 18 into 100%. So 5 times 18 is 90, and this total comes out to be 250. I just remember it from another question we did a couple of years ago. Okay? So that's how I figure out how much of that is water. मुझे पता चल जाएगा कितने percent आएगा. So percentage by mass is really easy. You just take every element that you have and you figure out the total MR, and then you're able to calculate its individual contribution to the mass. ठीक है? Percentage mass का फायदा कहाँ पे होता है? When they use a mixture to figure out how much of that element can be extracted. For example, here's a question. 4 tons aluminum oxide is electrolyzed, which means it undergoes electrical breakdown. Assuming it is 50% pure, how much aluminum can be extracted? So for this, I will try to figure out कि पहले तो मैं देखता हूँ कि इसमें से एल्यूमिनियम 100% प्योर एल्यूमिनियम का रोल इज देयर आर 2 एल्यूमिनियम where total we have 2 aluminum and 3 oxygen. 2 times 27 and oxygen is 3 times 16. That is the role of oxygen there. So according to this, I must get what? So MR is 48 plus 100 and this is 54. So I'll just multiply. So this is 52.9% of that is aluminium. So aluminium's percentage is 52.9%. In sample, you have 4 tons. So 4 times 52.9%. So that gives me, we are getting aluminium that is almost 2.12. Only have 50% pure sample. So we have a 50% yield, percent of what you would expect. So it will be 2.12 times 50%, and that comes out to be 1.6. How much aluminium can be. Now, can you figure out the percentage yield of this whole reaction? That if we would 4 tons of aluminum oxide, we only got 1.06 tons of it. How much of it is there? Now, the last thing is empirical formula. Empirical formula is actually really easy. It's a 3-step process. First of all, what is empirical formula? Empirical formula, आपके पास formulas होते हैं ना, they tell you how much of anything is present or the ratio in which it is present. So when I say calcium chloride, I'm saying that the ratio of calcium and chloride ions is 1 to 2. When I say uh, carbon dioxide, then I'm saying that one molecule of carbon dioxide has one carbon and two oxygen atoms. But that may be molecular formula or formula mass, a formula unit. But empirical formula is a little different. Empirical formula tells me the simplest ratio of elements in a compound. That's what empirical formula tells me. So, how do I figure that out? So, there are 3 steps to this. First of all, you find moles. Second step, you find the ratios. And that's how you figure out the empirical formula. Just 2 steps and you're done. बट क्वेश्चन में यूजली वो आपको मोल के अब नाम भी नहीं लेता. वो क्या करता है, वो आपको या मैस देगा या आपको परसेंटेज देगा. तो जो भी होगा ना, मोल क्या है, you take the mass. If they've given you the mass, you divide by AR. If they've given you percentage, you still divide by AR. क्यों? क्योंकि टोटल परसेंटेज 100% है, तो हम सोच सकते हैं कि अच्छा we have 100 grams of that thing. So it can be converted to mass again. And for ratios, you simply divide by smallest. Now, there are a couple of ratios that you need to know how to convert. For example, 1 by 3, 2 by 3, 1 by 2, 1 by 4, 3 by 4. These 4 ratios, you need to figure out how to simplify them. So, for example, 1 by 3 is 0.333. So, अगर आपको 0.333 मिलता है, that is 1 by 3. आपको 0.666 मिलता है, that is 2.3. You get 0.5, that is half, that's pretty straightforward. 0.25 is 1 by 4 and 0.75 is 3 by 4. When you get these values, you should be able to simplify it on your own. Okay? And then you figure it out what the formula is. So hold on, let me just open a worksheet for you guys and we can use that. They've given us percentage. So हम सबसे पहले इन सब के नाम लिख लेते हैं. Calcium, hydrogen. I did not put H2, I put hydrogen because we are talking about atoms. And oxygen again, O2 nahi likha, just oxygen. 24.7 of this, 1.2 of this, 14.8 of this, and 59.3 of this. Notice that I did not put the percentage sign because I'm assuming I have 100 grams of this, so I don't have to. Another thing, before you start with the question, make sure that the total add to be 100%. If it's not, then there might be an element you're missing out on. So this one is 100%. So I'll continue this. So 24.7 divided by 40 because wo uska AR hai. 1.2 divided by 1, 14.28 divided by 12, and this divided by 16. Basically, I'm trying to figure out moles. I have mass, I'm dividing it to find moles. So for the first one, I'll get 0.6175. You can write it as the whole thing or you can just leave it like that. This will be 1.2. This will be 1.23. This one is 3.7. Now I have to simplify. So for that, I'll simply divide it by the smallest. The smallest is 0.6175, right? So I'll divide them all by 0.6175. And remember, thoda bahut approximate aap kar sakte ho. When I do this, this will give me 1. This will give me 2. This will give me 2. And this will give me what? 6. So there you go. Our ratio will be Ca1, H2, C2, O6. And by the way, we can figure that out, that this can be CaHCO3 times 2. But ये हम अपनी तरफ से लिखते हैं. आप सिर्फ ये आंसर भी दे देंगे तो it's perfect. So the compound is calcium hydrogen carbonate or a combination of that. Now here's an important thing to remember. the ratio by which you simplify an empirical formula. So molecular formula divided by empirical formula, that equals a ratio. उस ratio को मैं n कह सकता हूँ, let's suppose. And turns out that is the same as molecular mass divided by empirical mass. What is molecular mass? It is the mass of a compound compared to carbon 12. What is empirical mass? It's the mass of the empirical unit. ये जो empirical formula से आता है इसको हम empirical unit कहते हैं. So it is the mass of empirical unit compared with carbon 12. So let me give you an example. Let's suppose I have glucose. Glucose का formula होता है C6H12O6 और इसका MR होता है 180. Now if I figure out the empirical formula, so I can divide all of it by 6 and I'll get CH2O. I've divided by 6, right? So the empirical mass here is going to be, I don't have to calculate the mass again. It will simply be 180 divided by 6, which is 30. Similarly, मैंने यहाँ पर division by 6 की है. अगर मैं वापस जाना चाहूँ, मैं multiplication by 6 कर सकता हूँ. And same is the case here. 6 से division या multiplication के through आप empirical formula से regular जो molecular formula है उसमें convert कर सकते हैं.